Hello, this is the Blonde Analyst, and today we will be going over SOA exam problem 13. This problem states, in modeling the number of claims by an individual under an automobile policy during a 3-year period, an actuary makes the simplifying assumption that for all integers n greater than 0, p of n plus 1 is equal to 0.2 p of n, where p of n represents the probability that the policyholder files n claims during the period. Under this assumption, calculate the probability that a policyholder files more than one claim during the period. So we are trying to find the probability that the policyholder files more than one claim during the period, and we have this formula. So what is this in a more formulated type of approach? So it states, or what we're trying to find is p n greater than 1. And we know that that is the same thing as 1 minus p n less than or equal to 1. And that is the same thing as 1 minus p n equals 0 and p n equals 1, because our range goes from 0 to infinity. So we just need to find this right here. Now let's look at our formula really quick. So it states that p of n plus 1 is equal to 0.2 of p of n. I'm going to put this in a fraction. 0.5 p of n. Let's write the first couple of terms to see if we could find some sort of rhythm or something along the lines that could make sense out of this. So p of 1 is equal to 1/5 p of 0. P of 2 is equal to 1/5 p of 1. But we have our p of 1 right here. So we could plug that in over here, and that is equal to 1/5 times 1/5 p of 0. And if we keep going, we'll see this pattern here of 1/5 times 1/5 times 1/5 times p of 0. And our 1/5 is actually repeated however many times are in here. So if we have k terms, we have 1/5 to the power of k, and then here is p of 0. Now, this is actually in a form that we should know, called the geometric. So if we know the sum of a geometric, then this should be pretty simple actually. So we know the sum of a term is 1. The sum of our probabilities is 1. So 1 is equal to the sum of our p of k here, from k is 0 to infinity, because this is just our probabilities. Now let's try to plug it in. So we have our 1/5 to the k p of 0, and our bounds stay the same. And the sum of a geometric, we should know, it's our first term, so this is a p of 0 over 1 minus whatever's in here. 1/5. And that's equal to 1. Our denominator goes to 4/5, and we're trying to solve for p of 0, so we're going to multiply both sides by 4/5. And we see that our p of 0 is equal to 4/5. So we have our n equals 0. Now it's the easy part. So based on our formula up here, or right here, our p of 1 is equal to 1/5 times 4/5, which is equal to 4/25. So going back up here, our p, let's have this lowercase just to keep everything the same, greater than 1 is equal to 1 minus, and we have our 4/5 plus our 4/25. Common denominators here, so this will be to 25, and then this will be to 20, so 20 plus 4, so that's 24/25, and that is equal to 1/25, or 0.04, which is our answer right